Hi, this chapter is about deep learning. Recently, AI or machine learning, they have been dominated by deep learning. Okay, so actually, all the chapters in this class are organized toward deep learning. And some machine learning algorithms like random forest are still used in many applications. So the ML algorithms are important as it is. And also they are important to understand deep learning, or we can use them with deep learning. Okay. And since we have another class for deep learning, so in this class, I'm going to talk about deep learning really briefly. So if you are interested in deep learning, then you can take a deep learning class. Okay. And this is the outline of this chapter. First, I'm going to introduce what deep learning is really briefly, and then I'm going to provide some neuroscientific basis about deep learning. Okay, and then I will compare shallow learning and deep learning. Okay, what's the difference and why deep learning works better than shallow learning? And then I'll talk about representation learning because representation learning is another name of deep learning. Okay, so I'll talk about some basic ideas and concepts. And I'll talk about just a few algorithms, a few representative algorithms. Okay. And then we'll talk about some issues and topics in deep learning. This is the first successful deep learning stories where AI or deep learning starts beating humans. So which means this AI got smart enough to beat human level performance. Okay. So the first one is German traffic sign recognition competition in 2011. So there are a lot of images, traffic sign images, and then we have to recognize these images. And before this competition, they actually checked the human performance, which is 98.84%. But the first team got 99.46%, which is more accurate than human performance. So this is actually the first story. Okay, and then the second ranked team had a similar performance as human performance. And these two teams are based on deep learning, CNN and CNN. We're going to talk about these CNNs later. And the third one is based on the random forest. I think you're already familiar with random forest. Okay, and then next one is Merck drug discovery in 2012. So there was a new drug discovery contest, and these guys, deep learning group from University of Toronto, these guys are just computer science people, and they wanted to join this competition. And then they downloaded the data and they trained the neural network, deep learning network, and then they submit the result and they won the contest. That's amazing story. Okay. And object recognition is one of the most popular successful stories of deep learning. Okay. And there is a famous image data set, which is ImageNet. Okay, this is not a neural network. This one is just a data set with lots of classes, lots of training samples and test samples. And in this data set, the task is simple. So given this image, then we have to recognize what it is. Okay, and there is a top 1 and top 5. When we predict the class, the model predicts the class, it actually generates the probability for the classes. And the true label is the most probable class by the model, then it is correct. Otherwise, it is false, incorrect. Then it is top 1. And top 5 says, as long as the true label is within the first 5 probable classes by the model, then it is correct. Otherwise, it is incorrect. Then it is top 5. Okay, so we have a top 1 and top 5. And these are the previous SOTA, 45% error and 25% error. And in 2012, Alex Krivsky proposed AlexNet in his paper, and he actually implemented a CNN model. And he trained this model with 2 GPUs for almost 1 week. And then his performance was remarkable. The improvement was huge. Since this paper, people started believing that the deep learning has potentials and deep learning is promising. So people started using deep learning since this paper. And the next example is speech recognition. So deep learning was applied to speech recognition before object recognition. But speech recognition is harder than the object recognition because in the object recognition we have one end-to-end deep learning model. So from the image to the label we have only one deep neural network. But in speech recognition systems we have lots of components back then. So we have a feature extraction and the acoustic model and the language model and decoder. So with all these components, then we can actually recognize this speech to text. But in 29, Jeff Hinton actually met speech recognition guys in Microsoft, and they actually took this idea. So they applied a deep neural network to replace this acoustic model. So before this deep learning, acoustic model was based on the Gaussian mixed model, and they replaced this Gaussian mixed model with deep neural network, and then they improved the performance. They tried a language model with neural networks, but back then the language model was based on the n-gram, and the n-gram was so optimized because the speed is quite important here. So when we decode, then it takes a lot of time if we use neural networks. So it was not practical. So as long as we use this kind of the system, speech recognition system, then we can replace this one with the neural network, but not the language model. Okay. But recently, there are many papers to recognize the speech to text directly with just one end-to-end neural network. And the next one is object detection. So object detection means given this one image, we have to detect all the objects that we are interested in. So in this image, we have to recognize dog and the bicycle and car. Okay. In around 2016, there were a couple of famous object detection algorithms like RCNN and YOLO and SSD. But recently, YOLO version 4 was proposed, and I think YOLO is most powerful or famous object detection algorithm. And in 2016, if you take a look at this table, the accuracy is quite good. And if you look at this frame per second, if it is 40, then this algorithm can be applied to the video real time. And the next application is neural machine translation. Before neural machine translation, there was a statistical machine translation. Actually, Google Translate was based on statistical machine translation before 2016 September. Okay, they actually replaced Google Translate with the neural machine translation. They call it Google Neural Machine Translation, GNMT. But anyway, since 2014 or so, people started thinking of machine translation as encoding and decoding. So if you look at this figure, so we have English sentence that we can encode and then we can decode. Okay, it's like an autoencoder. Okay, encoding and decoding. So this one should be the same as the original input sentence. Okay, this is a sequential autoencoder. And if we have English encoder and Korean decoder, then it is translations. But don't get me wrong, if we train the English encoder decoder in this way, and if we train the Korean encoder and decoder, after that, if we just combine English encoder and Korean decoder, we cannot have a machine translation, okay? Because this sentence representation is not semantic. So even with this English encoder and Korean decoder, we have to train with this network architecture. Okay, so input is English sentence and the output is Korean sentence. Then we have to train this neural network. Then we can have a neural machine translation. There were first two models. So Google actually proposed sequence to sequence model based on the LSTM. So they have encoder and the decoder. These are LSTMs. And based on this one, then they could translate. And also, almost at the same time, Montreal means Mila. They actually proposed another neural machine translation network architecture, which was based on the attention mechanism. And actually, this one, attention mechanism, is better than the Google sequence to sequence model. But back then, in 2014, 2015, they were in a competition. But finally, Google actually took this attention mechanism based translation. So now the attention mechanism is dominant. And this Google NMT was based on the attention mechanism, and they actually evaluated their translation system compared to the human translator. And based on their experiment, Google Translator is almost the same as human translator. And there's one thing that I want to point out. When we build up a neural machine translation system, we don't need the linguistic knowledge. Okay, so as long as we have a pairwise corpus, then we can build up a neural machine translation. And we need a lot of lines, sentences, like 4.5 million pairwise sentences. Then we can build up one nice translation system. Okay, so we don't need the linguistic knowledge at all. If we have, then maybe we can use it. Okay, in deep learning, at the beginning of this deep learning history, then people wanted to use just data without the domain knowledge or so. And the summarization is a kind of neural machine translation. So before this neural machine translation, there was no summarization. Actually, there were some people trying to summarize some text, but back then the summarization was based on just selection of some important sentences from the text. Okay, so it was not kind of summarization actually. But since neural machine translation was proposed, then it is obvious, it's straightforward. So the paragraph is input and the actual headline is output. Then if we just train the neural machine translation, then it is a summarization, right? Of course, we can actually adjust the neural machine translation network architecture, focusing on summarization. So in this case, we have a paragraph. So attention mechanism can be hierarchical. So we can pay attention on the sentence level first, and then we can pay attention to the word level. But anyway, basically, just the neural machine translation can be applied to the summarization. And the next one is text generation. In Japan, AI program wrote a short novel and it almost won a prize. And also, when we train the neural network with the Harry Potter chapters, then it can write a chapter. Okay, that's quite interesting. And also, there's another one. People trained a neural network with lots of film script. And then neural network could write a new script. And based on that script, they hired some actors and actresses. They actually made a film. So this is the first film based on neural network generated script. And then the next one is quite interesting too. Since deep learning was popular, then we could do this algebra with image and text. So it's kind of multimodal kind of computation. So if you look at this example, this is an image and this is text and another text. So this image minus blue plus red, and then if we search in the database, then these are the nearest images. So we actually subtract blue, color blue, and we add the red. So we have a similar cars, but with different colors. And also we can do another algebra, then we can change the color, and now we can have a similar cars with different color. And actually this is available in Google search. I got this image and I put this red, and when I search it, I got these similar images. So as you can see here, the car shape is quite similar, but the color is red. And the next application is image caption generation. So given this image, then we wanna have one nice sentence describing this image. Okay, that is the image caption generation. This one is exactly the same as neural machine translation, except the encoder. Encoder is based on the CNN. So CNN can encode the image, and then the decoder can actually generate a sentence like neural machine translation. So in this image caption generation, the attention mechanism is applied too. So when we generate one word, actually when we translate one sentence to another language, then we generate word by word. Okay. So likewise, in image caption generation, we generate the sentence by generating the words, word by word. So when we generate one word, we pay attention to specific area of this image. So when we generate the stop, we just pay attention to this stop signal. Okay. And also question and answering systems are kind of possible. And this question and answering system can be based on just the text. Okay. So given a text, then the system reads the text and then uh, the system can answer to some question, or we can have a Q&A system based on image like this. So given this image, then this is a question, then AI system can answer to this question, or given this figure, then the AI system can answer to some specific question. Okay, so these are not perfect yet, but getting better, and pretty soon it will be pretty good enough. And the next one application is some art. Okay, so we can actually separate the style and the content from image. So this is an image, and we believe that there is a content and the style, and they can be separable. We believe that, and then based on some system, then we can actually change the style of this image. So given this image, then this is a new style, then we can generate this image. So in this image, we actually get this content. There is a building here, but the style is exactly the same as this one. Or we can simply change the styles with another one. So in this case, we have a building. Here, this is a content, but with a different style. So this is possible.